What if everything we've learned about the cosmos is about to change forever? NASA's groundbreaking Next-Gen telescope has just delivered findings so astonishing, they're literally rewriting the textbooks. We're talking about discoveries that challenge our understanding of galaxy formation, the early universe, and potentially even the origins of life itself. Scientists are calling these findings the most revolutionary cosmic discoveries since the Hubble telescope first opened our eyes to the vastness of space. Are you ready to see the universe through a completely new lens and discover what scientists are truly finding? Welcome back to Space Prime, where we explore the most cutting-edge discoveries in space science. Today, we're diving into revelations that are fundamentally changing how we view our place in the cosmos. Cosmic Doorway Unlocked. The universe has just become far stranger and more wonderful than we ever imagined. NASA's James Webb Space Telescope, the most powerful space observatory ever constructed, is delivering discoveries that go far beyond pretty pictures of distant nebulae. We're witnessing fundamental shifts in our understanding of how galaxies form, how stars are born, and what the early universe actually looked like. This isn't just an upgrade from the Hubble Space Telescope, it's a completely different way of seeing the cosmos. While Hubble showed us the universe in visible light, Webb peers through cosmic dust and gas using infrared vision, revealing hidden structures and phenomena that were completely invisible to us before. The telescope's discoveries are so groundbreaking that they're forcing scientists to question theories that have stood for decades. We're seeing galaxies that formed much earlier than should have been possible, stars that behave in ways that challenge our models of stellar evolution, and cosmic structures that defy our understanding of how the universe developed after the Big Bang. Every week brings new revelations that expand our cosmic perspective. The data flowing back from Webb is so rich and detailed that astronomers are discovering new phenomena in images that were originally intended to study something completely different. It's as if we've been looking at the universe through a keyhole for decades, and suddenly someone opened the door. The telescope is revealing that the early universe was far more active, more complex, and more surprising than we ever believed possible. The implications of these discoveries extend far beyond astronomy. They're changing our understanding of physics, chemistry, and the fundamental processes that shape reality itself. Beyond the observable, the instrument. The James Webb Space Telescope represents the culmination of decades of technological advancement and international cooperation. Positioned 1.5 million kilometers from Earth at the second Lagrange point, Webb operates in the cold depths of space, where its massive mirrors and sensitive instruments can detect the faintest infrared radiation from the most distant corners of the universe. What makes Webb revolutionary isn't just its size, though its 6.5-meter primary mirror is nearly 3 times larger than Hubble's. It's the telescope's ability to observe in infrared wavelengths that are invisible to human eyes and most other telescopes. This infrared vision allows Webb to peer through cosmic dust clouds that completely obscure visible light, revealing star formation regions, planetary systems, and galactic cores that were previously hidden from view. The telescope's instruments are so sensitive they could theoretically detect the heat signature of a bumblebee at the distance of the moon. This incredible sensitivity, combined with its infrared capabilities, means Webb can observe the universe's earliest galaxies, light that has been traveling toward us for over 13 billion years, stretched into infrared wavelengths by the expansion of space itself. To put Webb's power in perspective, imagine the difference between looking at a candle flame from across a football field versus examining it under a powerful microscope. Webb doesn't just see more distant objects, it reveals details about cosmic phenomena that were completely beyond our reach before. The telescope's revolutionary technology includes adaptive optics that compensate for the tiniest vibrations and thermal variations, spectrographs that can analyze the chemical composition of exoplanet atmospheres, and coronagraphs that can block out the light of stars to reveal the faint glow of orbiting planets. These capabilities are opening entirely new fields of astronomical research. First light, first breakthroughs. The discoveries began almost immediately after Webb became operational, and they haven't stopped since. Astronomers have uncovered 300 unusually bright cosmic objects that may be some of the earliest galaxies ever formed, challenging our understanding of how quickly galactic structures could emerge after the Big Bang. These ancient galaxies are far more massive and well-developed than our theories predicted they should be. According to our models of cosmic evolution, the universe simply wasn't old enough for such large, complex structures to have formed, yet there they are, shining brightly in Webb's infrared images, forcing us to reconsider the entire timeline of cosmic development. Webb has discovered a new moon orbiting Uranus, designated S/2025U1, demonstrating the telescope's incredible ability to detect faint objects even within our own solar system. But this discovery is just the tip of the iceberg when it comes to Webb's revelations about planetary systems. The telescope has identified exoplanets with atmospheric compositions that shouldn't be possible, according to our current understanding of planetary formation. These worlds show chemical signatures that suggest completely different evolutionary paths than anything we see in our solar system. Webb has identified dozens of small galaxies that played a starring role in a cosmic makeover that transformed the early universe, revealing the process by which the cosmos evolved from a dark, hydrogen-filled void into the star-filled universe we see today. Perhaps most intriguingly, Webb's observations of distant quasars and black holes show that supermassive black holes existed much earlier in cosmic history than should have been possible. These black holes, containing millions or billions of times the mass of our Sun, appear to have formed when the universe was less than a billion years old. Not enough time for them to grow to such enormous sizes through conventional processes. The telescope has also revealed unexpected diversity in star formation processes. Webb shows astronomers new details, including knots, sheets, and clouds that are likely sculpted by magnetic fields, demonstrating that stellar birth is far more complex and varied than we previously understood. Unveiling the unknown, challenging existing theories. The implications of Webb's discoveries are forcing astronomers to fundamentally reconsider some of the most basic assumptions about how the universe works. The discovery of massive, well-formed galaxies in the early universe is particularly challenging to current cosmological models. Our understanding of galaxy formation is based on the idea that cosmic structures grew gradually through gravitational attraction, with small objects merging to form larger ones over billions of years. But Webb is showing us galaxies that appear to have formed much faster than this gradual process should allow. This discovery is leading some scientists to propose that the early universe underwent periods of accelerated structure formation, possibly driven by unknown physical processes or exotic forms of matter and energy that we haven't yet identified. The implications could reshape our understanding of dark matter, dark energy, and the fundamental forces that govern cosmic evolution. The detection of impossibly early supermassive black holes is creating similar theoretical challenges. Current models suggest these cosmic monsters should take hundreds of millions or billions of years to grow to such enormous sizes. Either our models are wrong, or these black holes formed through completely unknown mechanisms that operate much faster than anything we've observed. Some researchers are proposing that primordial black holes, objects that form directly from the collapse of dense regions in the very early universe, might be more common than we thought. Others suggest that the feeding mechanisms that power black hole growth might be fundamentally different in the early universe. Webb's observations of exoplanet atmospheres are revealing chemical compositions that challenge our understanding of how planets form and evolve. The telescope has detected water vapor, carbon dioxide, and other molecules in the atmospheres of worlds that orbit so close to their stars that these compounds should have been stripped away by stellar radiation. These discoveries suggest that planetary atmospheres might be more resilient and complex than we believed, with mechanisms for retaining and even regenerating atmospheric components that we don't yet understand. This has profound implications for our search for habitable worlds and our understanding of how life-supporting conditions might develop. The telescope is also revealing that stellar evolution processes are more diverse and complex than our current models predict. Webb has observed stars that appear to be aging at different rates than theory suggests, stellar explosions that don't match expected patterns, and stellar birth processes that occur under conditions we thought were impossible. The future of cosmic exploration. The discoveries Webb has made in its first few years of operation are just the beginning. The telescope is designed to operate for at least 10 years and potentially much longer, meaning we're only seeing the first glimpses of what it will reveal about the universe. Future observations are planned to target some of the most intriguing questions raised by Webb's initial discoveries. Astronomers are planning detailed studies of those impossibly early galaxies to understand how they formed so quickly. They're designing observations to probe the environments around early supermassive black holes to understand how these cosmic monsters grew so rapidly. The telescope will also conduct unprecedented surveys of exoplanet atmospheres, potentially identifying biosignatures, chemical indicators of life, in the atmospheres of distant worlds. Webb's sensitivity is so great that it could theoretically detect oxygen, water vapor, and other life-indicating molecules in the atmospheres of Earth-like planets orbiting nearby stars. Perhaps most exciting are the completely unexpected discoveries that Webb will make, phenomena we can't even imagine yet because we don't know they exist. The telescope's most revolutionary discoveries might come from observations that reveal cosmic phenomena that don't fit any of our current theoretical frameworks. The data Webb is generating is also driving technological advancement. The techniques developed to analyze Webb's observations are leading to new methods of image processing, spectral analysis, and pattern recognition that have applications far beyond astronomy. International collaboration around Webb's discoveries is fostering unprecedented cooperation between research institutions worldwide. The telescope is generating so much data and so many new questions that no single country or institution can hope to analyze it all, leading to collaborative research programs that span continents and cultures. The philosophical implications of Webb's discoveries are equally profound. As we discover that the universe is stranger, more complex, and more dynamic than we ever imagined, we're forced to reconsider our place in the cosmic story. Are we typical products of cosmic evolution, or are we something unique and special in a universe full of surprises? Webb is also inspiring the next generation of space telescopes and cosmic exploration missions. The discoveries it's making are driving the design of even more powerful observatories that will probe even deeper into space and time, potentially revealing the very first stars and galaxies that formed after the Big Bang. The universe that Webb is revealing to us is far more wonderful and mysterious than we ever dared to imagine. Every observation brings new questions, new puzzles, and new opportunities for discovery. We're living through a golden age of astronomical discovery, where our understanding of the cosmos is expanding at an unprecedented rate. As Webb continues its mission, peering ever deeper into space and time, we can only imagine what other secrets of the universe await discovery. The telescope has already shown us that reality is stranger than our theories predicted. The question isn't whether Webb will continue to surprise us, it's whether we're prepared for a universe that's even more magnificent and mysterious than we ever dreamed possible. The cosmos is vast, ancient, and full of wonders we're only beginning to understand. Thanks to Webb, we're no longer just observers of the universe, we're active explorers, uncovering secrets that have been hidden in the darkness for billions of years, waiting for us to develop the technology and wisdom to find them.